Sri Sai Ram. Hearty welcome to Sri Sathya Seva Gurukulam. Good morning, all of you. How are you? Fine? Okay. Be in good spirits, right? Now we are studying about quadrilaterals. Very interesting chapter. Now we'd like to invite you, when you come to the next class, you make a list of all the quadrilaterals which are there in your home. For example, the top of the table is a rectangle, is it not? The windows, they are also rectangles, some will be square also. So like that, make a list of all the quadrilaterals available in your home. Okay, come prepared, right? So now just let us recall what we have studied in the previous class. We have studied about plane curve. Any curve drawn on a plane surface is called as plane curve. What is plane? Say this board is a plane, your book is a plane, your table is a plane. Okay? So they are plane surfaces, and any curve drawn on that will be, when you say curve, there are two types. See, this type of curves are called open curves, is it not? And this type of curves are called closed curves. So these are all closed. Okay, and they are in the same plane. Also we have studied about polygons. What are polygons? Polygons are plane figures having 3 or more sides. They are made up of line segments. So the line segments will be there, and naturally we have vertices. For example, a triangle is the simplest of polygons. And a square is also a polygon having 4 sides. Correct? And when you say polygon, there are 2 types. One is called convex polygon. Another is concave polygons. Convex polygon is one in which only diagonals will be inside the polygon. See here, the diagonals are inside the polygon. These are called diagonal. What is diagonal? The line joining the opposite sides, opposite vertices. Okay. So here, if ABCD is this is called convex polygon, because the 2 diagonals will be inside the polygon. This is called concave polygon, because one of the diagonal will be outside, like this. This will be outside. So this diagonal is outside the polygon, and therefore we call it as concave polygon. And one more difference is, there is no reflex angle in case of convex polygon. Here there will be one or more than one reflex angle will be there. What means reflex angle? Reflex angle means angle more than 180. Angle more than 180. So this angle will be more than 180. It is called reflex angle. So these are the 2 types of polygons what we come across in our daily life. Also we have seen, this is what I was telling you now, and it need not be only 4 sided, it may be 5 sides, 6 sides and so on. There also we get convex and concave polygons. Okay. Also we have seen about regular and irregular polygons. What will be regular polygon? Regular polygon is one wherein all the sides and all the angles are equal. For example, you have come on, can you name this figure? It's a rough figure I am drawing, not exactly according to scale. What is the figure called? Anybody? Yeah, it is called hexagon. Hexagon. Why it is called hexagon? There are 6 line segments, and here it is called regular because, of course, there may be slight change if you take a scale and all, but you can do correctly because the sides and angles are equal. If the sides and angles are equal, do you know what is the angle? Each angle, interior angle, it will be 120 degrees. Sides are equal, angles are also equal. And the same thing, if the sides are not equal, then we call it as irregular. Some students will be there, will be irregular to classes, and some boys will be there, or girls also, they will be irregular for homework. They don't do homework correctly. Don't be like that. Be regular. Okay? Always one should have a discipline in life, about which we will see in the last. Okay? Now coming to the home assignment. Here are some figures. You have to classify them on the basis of the following. So just observe these figures. How many have done this? Raise your hands. Okay. Now the first question is simple curves. Can you think of simple curves? You have 1, 2, 1 is here, 2, then you have 5, 6, 7. These are called simple curves, and also simple closed curves. Simple closed curves also 1, 2, 5, 6, 7. They are closed because all the line segments or the arcs are joined to each other. They are closed. So simple closed curve is 1, 2, 5, 6, 7. Next question, polygons. How many of them are polygons? Answer is 1 and 2. So these are polygons. So 1 and 2 are called polygons. Why they are called polygons? Because they are made up of line segments, and this is the two types. This is called convex polygon, this is called concave polygon. So convex polygons, how much? You have number 1 and 2. So no, this is only 2 is a convex polygon, not 1, only 2. Convex polygon. And see, these are all not called polygons because they have got arcs. When the arcs are there, we can't call it as polygons, only 2. And one more is concave polygon. Concave polygon is only 1. That is number 1. Number 1 is the concave polygon. Why it is called concave? Because one of the diagonal is outside the figure. Here all diagonals will be inside. So this is what you have to classify. Is it okay? Shall we go to second problem? Okay. How many diagonals does each of the following have? A convex quadrilateral will have 2 diagonals. And how it will be? For example, square is a convex quadrilateral. What is a diagonal? Diagonal is a line segment joining the opposite vertices. Can I name the diagonals here? One is AC, correct? Another is AC is one diagonal, and BD is another diagonal. So, line joining the opposite vertices is called diagonal. So, that is how you write it. It may be square, it may be rectangle or rhombus, whatever it is. All of them will have only 2 diagonals. In case of hexagon, there are 9 diagonals. You can try this carefully. I am drawing a rough figure. It is not exact figure. 9 comes. You can name these vertices as A, B, C, D, E, F. Now you have to join to opposite vertices. From A, how many can see? One is AE, AD, AC. You can also try. So 3 diagonals there. From B, how much? From B to D1, B to E1, B to F1. So that is number 4, 5, 6. So 6 diagonals over. From C, some C you have CE is there and CF is there. It is 7 and 8. From D, all are over, right? DB is over, DA is over, and DE is not there. DF is there. You can have one DF. So that is 9th one. So totally you will have 9 diagonals. Okay. How much a diagonal triangle have? No diagonal possible. Is it not? So in a triangle, you can draw only altitudes but not diagonals. Okay. Therefore you write 0 is the answer. What is a regular polygon? Just now we discussed. A regular polygon is a polygon having equal sides and equal angles. Note down. Equal sides and equal angles. State the name of regular polygon of 3 sides. What do you call it? Triangle. 4 sides is a equilateral triangle, not triangle. So you have both equiangular, means all angles are equal. Equilateral means all the sides are equal. And now you have to name them. With 3 sides either, we call it as equilateral triangle. Means all the 3 sides are equal. Suppose you have a triangle ABC. Of course, most of you can pick up easily. Just for those who can't understand, I am writing. Here AB is equal to BC is equal to AC. So 3 sides are equal. When you say sides are equal, angles are also equal. A is equal to B is equal to C. And in case of square, you will have 4 sides and all the angles are equal. Correct? all the four sides are equal. Suppose you name it as PQRS. Here PQ is equal to QR is equal to RS is equal to PS. All the sides are equal and all the angles are equal. Okay, therefore we call it as regular polygon. 6 sides, what do you call it? Regular hexagon. Hexa, just now I shown it. Hexa means what? 6 sides. So if the 6 sides are equal, we call it as regular hexagon. Something like this. It is not exact figure, approximately. So this is called regular hexagon. Here all the sides are equal, all the angles also equal to 120 degrees. Okay, therefore it is called as regular polygon. Noted? Okay. Now we will see today's topic. Angle sum property. We have seen in the previous class 7. The sum of the 3 angles of a triangle is 180 degrees. In the same way, we can get the sum of 4 angles of a quadrilateral. So, suppose you have a triangle ABC. Come on, name the 3 sides. Name the sides AB, BC, CA. Name the angles. Angle A, angle B, angle C. What is the sum of the 3 angles? It is equal to 180 degrees or 2 right angles. So in the same way, this is already proved in the 7th class. Now we are coming to the 8th class, that is about quadrilateral. So there is a small activity here, that is draw a quadrilateral. It may be any quadrilateral. What is the meaning of the word quadrilateral? A polygon having 4 sides. What are the 4 sides here? AB, BC, CD, DA. And what is this AC called? AC is called diagonal. So you can try in a paper. Okay, draw a quadrilateral, draw a diagonal. And then what you must do? Measure the angles. See here, name it as 1, 2, 3 for this triangle. Measure it. Similarly, measure the angles 4, 5, 6. Okay. And if you measure it, what do you find? The sum of the 3 angles is equal to 180 degrees here. And it is also equal to 180 degrees here. Of course, measurement may be different, but sum is 180. So 180 plus 180, how much it becomes? 360. So what do you get it? So take any quadrilateral ABCD, divide it into 2 triangles by drawing a diagonal. You get 6 angles. Angle 1, 2, 3, 4, 5, 6. So if you add all that, what do you get? If you add all these angles, angle 1 plus 2 plus 3 plus 4 plus 5 plus 6 is equal to 180 plus 180, that is 360 degrees. How many right angles? Come on, 360 degree means 4 right angles. 1 right angle is equal to how much? 90. 2 right angle? 180. 3 right angles? 270. 4 right angles? 360 degrees. Correct? And now we will extend it to other quadrilaterals and other polygons. Okay. So each figure is divided into triangles and the sum of the angles is deduced from that. So come on, draw the figures. Of course, it is in textbook, you can just copy down. If you don't have textbook, you copy down. So this is a triangle. In triangle, there are 3 sides. and sum of the angles is 180 degrees. In case of quadrilateral, there are 4 sides and 4 angles. So, there are 2 triangles here. So, sum of the angles is 2 into 180. How do you got to 4 minus 2? The simple way of remembering. However much side is there, sides are 4 here, minus 2 into 180. See here, this is one triangle, this is another triangle. So, sum of these two is 360 degrees. In case of this, there are 5 sides are there. So, you have 3 triangles, 5 minus 2, 3 triangles. Sum of one triangle is 180. So, 3 triangles means 3 into 180, that is 5 minus 2 into 180. That is how much? 540 degrees. So, this becomes 540 degrees. It need not be equal, angles may be different, but total must be 540. In this case, you have how many triangles? By drawing diagonal from one point, you have 4 triangles. So, 6 minus 2, that is 4 triangles. One triangle is 180, 4 triangle is 180 into 4, that is 720 degrees. So, this will be 720 degrees, sum of all the angles. Here this is 360 degrees, this is 180 degrees. Like that you can go on extending. Suppose you have 7 sides, how much? 7 minus 2, 5 into 180. 8 sides, 8 minus 2, that is 6 into 9, 180. Like that you can extend it to any number of sides of a polygon. Okay, this is one of the methods of remembering things. Okay, so 7 means 7 minus 2 into 180, that is 5 into 180. Note down, 18 5s are 900 degrees. This is 8 into 180. 180 means 18 8s are 144. 144 followed by 0, 1440. Like that you can go on extending. Okay, what you must do? Number of sides minus 2 into 180, that is all. Suppose you have n sides. There is a triangle, say let us, there is a polygon of n sides. What is the formula then? Becomes n minus 2 into 180, correct? Or this 180 can be written as 2 right angles. 2 right angles, that is equal to 2n minus 4. So much of right angles. That is the formula actually. Sum of all the angles of a polygon can be given by the formula 2n minus 4 right angles. Each angle how much? 2n minus 4 by n. That is each angle. Okay. So, that is for your information. And now we will see, work out some more problems on this. Find the value of x, y, z. What are x, y, z called? They are exterior angles, correct? First to do orally, say 90 plus 30, 120, this will be 60. Now, if this is 90, the adjacent angle will be 90. If this is 30, adjacent angle will be 150, because sum of the two angles is 180 degrees, straight angle. This is 60, it becomes 120. Now they are adding, they are asking if you add all these things, how much you get. So x becomes 90, y becomes 120, Z becomes 150. Total it is 360. I already studied this in the previous class, how it becomes this. This is called linear pair. When a line segment stands on another line segment, we have studied now, remember? So suppose you call it as AB, this is C, this is D. When a line segment stands on another line segment, this is a straight line, this is a line segment. So if this angle is 30 degrees, how much will be this? That is called linear pair. So sum of these two is 180. In that 180 subtract 30. Then you get 30, 180 minus 30 will be 150. That is called exterior angle. The sum of the interior and exterior angle will be equal to 180 degrees. Similarly, same way here also. Sum of these two is 180. If this is 60, exterior one big one, that is called exterior angle, becomes 120. Here also, interior angle is 90, therefore exterior it becomes 90. Add all that, that gives 360 degrees. Noted? Shall we do one more problem? Same type with one more angle. This is about quadrilateral. First you must find out this angle. How much it will be? In a quadrilateral, what is the sum of all the angles? 360. Is it not? Now we will do one thing. We will name it A, B, C, D. Okay. So in quadrilateral, for those who can't understand, I am writing down. In quadrilateral, come on, name it A, B, C, D. Now, so what are the sum of the angles? First is angle DAB. Next is angle ABC. Next is angle BCD. Next is angle CDA. Sum of all this is how much? 360. In this, DAB is given to be 60. Then you have ABC is given to be 80. BCD is given to be 120. And CDA you have to find out. Is equal to 360. So CDA will be equal to 360 minus 60 plus 80, 140, plus so 140 plus 120 becomes 260. So this angle becomes 100 degrees. CDA becomes 100. Now again same principle, linear pair formula you apply, and suppose you call it as P here, Q here, R here, S here. Okay. So angle X means what? Angle BCR. BCR is equal to 180 minus 120. That you call it as X. Is it not? It is equal to X, 60 degrees. This is called linear pair. What do you mean linear pair? We also call it as adjacent angles. Sum of the adjacent angles. Similarly, Y. Where is Y? y is nothing but ABQ. ABQ is equal to y is equal to 180 minus 80. Of course, you need not do all this, but just for your information, I am doing this. And similarly, you have Z, that is DAP. DAP, also called as Z, is equal to 180 minus 60, that is 120. Lastly, W, that is CSDC or CDS, is equal to W, 180 minus 100, that is 80. Suppose you add all these things, how much you must get? X plus Y plus Z plus W should give, see, X is here 60, 160, 280 plus 80. So, this is a very important result. Sum of all the exterior angles of a polygon, it need not be quadrilateral, it may be pentagon, hexagon, etc., is equal to 360 degrees. Is it clear? Very happy. Okay. Now, home assignments. What is the sum of the measures of angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? So, that is a question. Second question, find the angle measure of x in the following figure. So, value of x you must tell in this and also in this. Okay. So, now let us see what Bhagwan Baba says. Bhagwan Baba says, discipline trains you to put up with disappointments. Every rose has a thorn. So, we should be disciplined. 3 Ds, discipline, duty, devotion. These are very important for improvement of the personality. So, if you are disciplined, coming in time for the classes, going also in time, everything in time in all places, doing homework in time, all this will will give you a strength to overcome the disappointments. Okay. So, come prepared with the answers. Thank you.